Good morning, students. Today we are going to start chapter number 6, the chemical reactions. We have already studied in the last chapters that reactants form products during a chemical reaction. The substances which react with each other are called the reactants, and the substances formed during the chemical reaction are called products. The products are formed by the breaking or combination of the reactants. What is a chemical reaction? It is a process in which one or more new substances with totally different properties are formed during a chemical reaction. In this, the bonds between atoms or molecules break, which are present in the reactants, and the atoms rearrange themselves, forming new bonds in the products. During this whole process, energy is either absorbed or released in the form of heat or light. Chemical equations. It is the symbolic representation of the chemical reaction by using symbol and formula of the substances involved. The chemical reactions can be represented in the form of word equation and chemical equation. But the chemical equation is the easy and time-saving way of representing any chemical reaction. So here is an example. We have given a word equation for the formation of carbon dioxide. Carbon plus oxygen gives carbon dioxide. And in the chemical equation, we are using the symbols for this reactants as well as the product. C plus O2 gives CO2. On the left hand side, the reactants are written, and on the right hand side, the products are written. Types of chemical reactions. In the chapter, we are going to study about 4 types of chemical reactions. Combination reaction, in which 2 reactants combine together to form a single product. The decomposition reaction, in which the reactant is a single compound which breaks down into 2 or more than 2 products. The displacement reaction, in which a more reactive metal displaces a less reactive metal from the compound. Here you can see AB is a compound which reacts with a more reactive metal C. C is more reactive than A, so it can displace A from the compound, and finally we get the products CB and A. And 4th type of reaction, the double displacement reaction, in which the exchange of radicals take place. So here is the compound AB and CD, where C will react with B and A will join with D, forming the products CB and AD. So one by one we will study about all these reactions in detail. The combination reactions, they are also called the synthesis reaction. Here 2 or more substances combine to form a single substance. Here also we have 3 kinds of reaction. The first kind, in which 2 elements combine to form a compound. So here iron, an element combines with sulfur, another element, and in the presence of heat, on heating, they form iron sulfide. This triangle means heat. On providing heat, they combine to form iron sulfide. Second type of reaction, in which an element combines with a compound. So here carbon monoxide is the compound and oxygen is the element, and on heating they combine to form carbon dioxide. Third type of reaction, in which 2 compounds react together to form a product. So here we have taken example of calcium oxide. It reacts with water and forms calcium hydroxide. Here's an activity to show the combination reaction between two elements. The materials required for this are a dish, a pair of tongs, magnesium ribbon, an eye protection mask and a burner. The procedure for it is as follows. First, we wear the eye protection mask before starting the experiment. Place the dish on the table and hold the magnesium ribbon just above the dish with the help of a pair of tongs. Now we burn the magnesium ribbon with the help of a burner. We will observe that the magnesium ribbon burns with a dazzling white flame and produces a white powder of magnesium oxide which gets collected in the dish. This shows the combination reaction between magnesium and oxygen to form the magnesium oxide. Here's one more activity to demonstrate the combination reaction between two compounds. For this, the materials required are a long glass tube, cotton wool, 2 rubber corks, ammonia solution and hydrogen chloride. The procedure for it is as follows. We place a long glass tube horizontally on the table. Divide the cotton wool into two parts. Soak one part in ammonia solution and the other part in hydrogen chloride. Fix both the soaked cotton wools on each end of the tube and close the tube by fixing the rubber corks on both the ends. Leave it for few minutes. After some time, we will observe that a white ring of ammonium chloride is formed in the tube. The white ring is formed due to the combination reaction between ammonia and hydrogen chloride. Decomposition reaction. In this type of reaction, a compound breaks into two or more simpler substances by the action of heat, light, or electricity. It is again of three types which we will show by the examples. In first type, a compound can break down into two different elements like here 2H2O in the presence of electric current. When electric current is passed through water, it divides into hydrogen and oxygen, two elements. Second type of reaction in which a compound forms a compound and an element like potassium nitrate. When heated, this triangle sign means heated. On heating, it breaks down into potassium nitrite and oxygen. The third type of reaction is in which a compound on heating breaks into two compounds. Calcium carbonate on heating till 100 degrees Celsius breaks in calcium oxide and carbon dioxide. Here again we do an activity to show the thermal decomposition of compound. Thermal decomposition means breaking of a compound in presence of heat or breaking of a compound on heating. So here the materials required are a boiling tube, a clamp stand, burner and copper nitrate. We take some copper nitrate in a boiling tube and fix it on a clamp stand. Heat it for some time. After some time, we'll observe that reddish brown fumes of nitrogen dioxide are coming out from the tube along with oxygen, which can make a glowing splinter burn brightly. Also, when the heating is stopped, a yellow solid of copper oxide is formed. Thus, we conclude that on heating, copper nitrate decomposes into copper oxide, nitrogen dioxide, and oxygen.